welcome everybody to this seminar about PID tuning during plant startup. My name is Christian Mons, the APC team of IPCOS. Now this is the first webinar after our summer break. So from now on we will continue with the tradition to have monthly presentations about topics that are close to our and also your heart, I think. Today we want to give you our view on what and why you can do regarding base layer control during plant startup. We get regular requests to optimize DCS systems, and very often these requests are coming 10 years after they put the DCS in operation, which means that in these 10 years a lot of money has been lost because our clients are operating with suboptimal base layer controllers. Yeah. Today we have Michiel Huizer as our presenter. Michiel has a lot of experience with the practical aspects of PID tuning and APC projects. He is also our PID course teacher. So from his experience in the field and during courses, he can help us and help you to see the bigger picture on what the advantages are of doing correct one times right PID tuning during plant startup. Most of you already know IPCOS. I will anyway give you a very short 2-minute introduction to the company and also regarding the agenda. So first a small introduction about IPCOS, the IPCOS role in plant startup. So what can we do for you? The different project phases that we use, and I think that also you should be using, or we suggest that you should be using. We will give you a couple of examples. And at the end, you have the possibilities to raise your questions. Since everybody is muted, the idea is that you raise all your questions via the chat windows from WebEx. So we will collect all the questions here, and then I will raise them to Michiel, who will answer them. So that would be the right way to proceed. Good. Introduction of IPCOS. So we are offering expert process control services. So what does that mean? That our engineers, they combine a lot of process know-how with process control experience. Yeah, so that is the key to success. If you want to do successful control optimization project, is knowing the process and knowing controls. Now what you see here on these slides are pictures of people. Not about computers, not about pipelines, reactors and distillation columns, because it's all about people. These are the experts that are working on your premises to optimize your plants. So that is therefore important. Our engineers who work around the world offering these expert control services. Yeah, at the bottom right is the town hall of Leuven, a very nice building. So that's very near to the headquarters of IPCOS. Good. So we are operating out of one of our 5 offices around the world. So Leuven, Boxtel, where Michiel and I are at the moment, our Cambridge office, Chandigarh office in India, and Abu Dhabi. That does not mean that we don't do projects in, for instance, Australia, Africa, South America, and North America. No, we are operating globally out of these 5 offices. Sometimes we work with partners here and there. There where it has an advantage, giving languages and so on. But all our engineers that are working at your site are coming from one of these 5 offices. Yeah. So what do we offer? As an independent process control service provider, what does that mean, independent? So we are not linked to any DCS vendor, which means we can work on any common DCS system that you might have, but we also offer services which are independent of the APC technology that you have chosen. So we offer services based on all common APC technologies you can find on the market. So we do studies and audits just to compute what the benefits might be of an APC system, but also to check how good or how bad your base layer control system is operating at the moment, and what we can do to help you. Yeah. So then of course we do the PID tuning and the base layer optimization, the tuning, but also the redesign of control philosophies. We offer complete advanced process control projects, which means turnkey projects, but also the maintenance of existing controllers. We give control training for APC and PID, and we also offer alarm management services. If you want to have more information about one of these topics, please let me know. Send me an email. You will find my email address at the end of the presentation on the slide, so that we can discuss. Yeah. So here is an overview of some of our customers. Most of them here on the slide, they are already customers for at least 5 to 10 and even 15 years. So that means that probably we're doing a good job at these sites of our customers. So, okay, I think that's about it. I will give the virtual floor now to Michiel, who will introduce you in PID tuning for plant startups. Michiel, it's yours.
Thank you, Christian. Yeah, good morning, everybody. So let's start with the presentation. So PID tuning for plant startup. Before we go talk about process control, just have a minute to recap. What is PID control? What is it doing for you? What is it doing in a plant? So the PID controllers provide, let's say, the basic stability for your plant, automatically keeping flow, pressures and temperatures at certain set points. So these will be typical your key variables that will also decide on quality and throughput. So how did they do that? Generally, what they do is they reject disturbances. So this can be disturbances coming from other units. This can be ambient temperatures from outside. This can be interacting loops, interacting with the PID loop that needs to be on a certain set point. So in general, disturbances. What they do is they provide a certain decoupling. That means if you change a certain valve, then you can have, let's say, 2 or 3 effects which you don't want. You want to have decoupled effects. So only the prime most important temperatures and pressures need to stay on set point, and you should be able to change them without influencing the rest. This all has a result that it will reduce the operator dependency. So an operator has just less work on the panel, and this is finally what we want, because he can concentrate then on actually pushing the process to its best operating point. Another important thing, I think, is it will reduce the number of alarms rates. So again, this has to do with the operator being less busy. So if we look at the global look on the plant commissioning on the phases, you can say you have the mechanical completion and integrity checking. Then usually you go to something like a pre-commissioning and operational testing. And this is all before the plant is actually running. And then we'll come to startup and initial operation. This is actually where the controllers will become active for the first time. So this is an interesting period for the plant. So you have to push the plant from, let's say, an initial operation to a level that is sufficient to be able to stand the performance and acceptance testing. After that, probably you will go to let's say, a post-commissioning phase, where you will bring the plant to a normal operation. There will be certainly some outstanding punch items, and you'll probably have an extra focus on operational data and consistency of your plant. Yeah, so we know that this period of initial startup is a very stressful time. There will be a lot of people working around the clock to prepare for that initial startup. And during that period, of course, there's a lot of challenges to tackle that were not foreseen, let's say. So things you can encounter is in general mechanical problems, you can have safety issues. We see a lot of instrumentational problems. You also have to do with material demands, energy demands, and you have to deal with the change in raw materials, maybe disturbances coming from the outside world. Yeah, so in the ideal scenario, you will bring your process variables to a desired value and keep them there, independent of what else is happening in your plant or what's happening, let's say, in the outside world, what you cannot control. And that's actually where PID control comes in. So in theory, PID controllers will do this for you, and what we often see is that PID tuning has not got the intention it needed during plant startup. So the message here is you actually need to involve an expert for process control. You need to give process control enough attention, and this will give you the benefit of moving faster and staying at a full plant capacity. So knowing that that PID tuning is often not done well during startup, and knowing that PID control is very important, how can we help customers? What we normally do, we do a thorough analysis of your plant, and we can help out with control performance on the spot, even during startup. So that's what highlighted here in red, so the troubleshooting of the control performance, and also helping out moving that plant to full operations. Although it might seem that it's more stress to have another company running around the plant at that moment, the reality is that we will make life easier, let's say, for the DCS engineers, the process operators, and the process control engineers. Because every loop we tune and every variable we improve will add to the total stability of the plant and will improve operations immediately. So after, let's say, in the post-commissioning phase, you would have another, let's say, set of job you can do. You have you have achieved that your plant is running, you have achieved that you have your performance trials and passed your acceptance test, but still there will be the possibility to optimize your plant, to have more adjustments, really look in detail what we can do to keep you running as efficient possible with, yeah, let's say, the best quality. So as an example, IPCOS can identify likely challenges. Already prior to startup, you can do a lot of work. Typically what we see is the typical situation here during the construction and automation phase, that there are default tunings put into the PID loops. Something in this table. And based on this table alone, I can already say, based on our experience, that the PID loops in general will be very bad. A lot of PID loops will not work and will be put in manual, especially during a plant startup. Other will be working but not really efficient and will cause problems further in your process. So this is one typical situation, DCS tuning, so default tuning. Another common problems are blaming tuning for hardware problems. So you really need to identify, is this PID loop misbehaving, or are these hardware problems, or are there disturbance sources? Or a disturbance source is another loop, so an interacting loop. Yeah, so these are typical problems we see. Furthermore, you have the correct use of control structures, ratio controller, master slave loops, where to use them, where not to use them. the use of feed forwards. Sometimes they are implemented not correctly, or they are tuned incorrectly. And then you have more measurement type of things and settings like wind up, filtering. Is that used? How is that used? And is it used properly? Sorry, I'm getting ahead of myself. So if you look, if we get involved in plant startup, what is typical work we do? So first we'll start off with the preparation. So before we get to a plant, we'll investigate the process. Every plant is different, we know this, and this is very important. So we get familiar with the process, we get familiar with the plant. And we already identify items that could be or pose a challenge during startup and also during normal operations. And believe me if I say from experience, we know where to look for trouble. So based on what we identify, we'll make a tuning plan. So we're not tuning in the way that you just focus on the loops that have a problem. No, you have a structured plan where you go from front to the back through your plant, and you make sure that you really focus on the most important loops and keep that plan stable. So having a structured plan is very important. So this is actually what we do before we come to the plant, before we come on site. Then if you look at the work we do on site, is that first thing we do is actually set up a data collection. And what we often see is that data collection is present in a plant, but it has, for instance, data compression, or it's not fast enough to really tune loops. It's designed to look at, let's say, the process variables. It's designed to judge what's the process doing, not what the loops are doing. They are much too fast. So what we do is we set up a data collection, which is fast, which has no compression. And this will allow us to really analyze your plant, really look at all the loops, and also judge, let's say, the next day, if you make a change, is it improved or is it not? And so it will provide actually a lot of information to us. Then of course we'll start to review and optimize the plant following the plan, following a structured way. And what we then often see is that because we are working there in your plant, we are a bridge between, let's say, the process engineer and the automation engineer. We are used to being in between both, let's say, using APC projects and also looking at base layer. Another thing what will often happen is that we troubleshoot and identify hardware problems because we are looking in details at those loops, and we can judge if it's really a problem of your PID controller. Yeah. So these are the typical things we do when we are on site, and I would say it's also keep in mind that the data collection, actually seeing what you are doing, it's a very important thing. So what are the typical results if you focus on PID tuning during a plant startup? You will be able to reduce the time from, let's say, the really initial startup to the time you can start with performance and acceptance testing. Because you're not moving around from one loop to the other, but you're really looking at the whole plant in a structured way. You can really reduce the time before you have a stable operation. This is of course a big benefit. This will also reduce the load on operators. The more loops you have running in auto control, so really running on the key temperatures or key pressures, the less time you have to spend on your DCS correcting valves, let's say. So, and this will reduce the load on the operators a lot. So having your plant running on auto control is very important. Of course, what also helps is if you have to control the correct base layer structures in place, and well, as mentioned before, you have implementation and hardware problems, and all these together will make a very busy day for an operator, and everything you can do to reduce that will help out and move you faster to actually your acceptance test. Sorry. Another thing you have, if you have managed to get through your acceptance test and your performance testing, you need to stay at a full production rate and be stable at the full production rate. So you will move to, let's say, a more normal production. And this is also something we can really add to, because you already looked in detail. The whole plant is just more easy to manage, more easy to control. Of course also, and this is a bit, let's say, if we are done with the non-critical loops and you're done with the testing, you can really tune also the less critical loops, yeah, and really improve total stability. And this will not be straight obvious, but every loop that's oscillating is actually introducing some instability and will have some small effect maybe. But if you tend to all things, you will have a very smooth plant, more stable plant. Another thing you can do is, of course, identify disturbance sources. So this can be from another unit, and try to have a strategy to mitigate them. So I think based on what we've talked about so far, is there's a lot of benefit for the end user. Yeah? If you can achieve stable plant operation much faster, so there's a real benefit in terms of time, and we'll have a more reliable plant. Yeah. And if you have more PID loops in auto, you have a better tuned plant, you can also achieve a faster startup, which is not only important for this startup phase, but also for the entire plant life. So another question you may ask, so what's in it for the EPC? We know that EPCs typically don't want another third party involved in the performance testing and acceptance testing and moving forward and moving towards that. The EPC often fears that the third party might make life more difficult, but in reality it's the other way around. We'll make the life of the EPC more easy and help him out identifying problems, help him out in tuning the base layer, so to achieve guarantees much faster. So just some examples of the work we have been doing. I've picked just 2 customers in general, just to give you an idea of the things we saw there. So the first is actually a vanilla plant in Russia, and we were present during the initial startup phase. And as you see, we were involved in tuning a lot of kinds of PID loops, a lot of level loops, pressure loops, pH loops, temperatures and flows, so more or less most of them there. And these were located in different subjects as wastewater treatment, some reactors, purification and glorification. This was actually looking at the plant as a whole. Now if you look at the common problems that we saw there, there's actually one I haven't mentioned before, and that is switching sequences. So these were polymer reactors. So we changed their PID structures, we changed some master-slave controllers, introduced some ratio controllers. Changing of PID equations, sometimes really important. What do you want to achieve? Do you want set point tracking? Do you want disturbance rejection? So that is something you need to look at, and especially in which case you have a recipe, you really need to focus on that. Also, when you have changes, so smooth switching sequences, we looked a lot of set point and output tracking logic. So, and here I mentioned another couple of common problems I already mentioned before, but just to post them to you. Now, if we do a project, we usually for the more difficult loops, we'll use our model-based tuning tool, which is called aptTune, and we start off with the stepping open loop, and we'll make a model. And what you see here in the plot to the left is actually the model of the excess interleaved content. Now, if you look at the red line in the other plot, that would be how a step response would be giving the default tuning. And you see it's quite oscillatory. It takes a long time to reach set point in this case. So just to illustrate how bad can it be if you have a default PID parameters in place. And of course the blue line is what we ended up with after using this modeling tool. So again, this is just to illustrate the need of looking at those things. Another project we had is batch reactors in Belgium. We were actually involved also in the initial startup phase, working side by side with the EPC in this case. And the main loops that were looked at there were temperature loops, very slow temperature loops, and pressure loops. And again, we had some, the most common problems encountered were the structures of PID and the reactor recipes, so how you move from one to the other. And in this case, there were a lot of recipes on one reactor. So what happened actually that we came up with, let's say, a set of benchmark rules, benchmark recipes, and we tuned all the reactors using these benchmark recipes. And that worked very well. It took some time to get the right benchmark, let's say, but after we have tuned the benchmark recipes, the customer would do its own performance and validation tests after us. And what we found is that if you think about the right benchmarks, that you can really tune those, and we passed all them the performance and acceptance testing later on. Of course, there were a few reactors that were special that we had to do another round, but in most cases this worked very well. So just two examples, very short, very in an overview way, what we did at some customers' sites. And of course, if you want more details of our projects of the past and which customers we went to, don't hesitate to contact us or to contact Christian, and he will be able to provide you with more details about the work we've been doing.
Good. Okay, Michiel, thank you very much for the nice presentation. So we still have time for questions and answers. So if you have questions, please raise them through the chat box of WebEx. Already some questions came in, and let me start by thanking somebody from Trinidad who is raising questions. So that person woke up about 5:30 in the morning to participate at this WebEx meeting. So thank you very much for that. And so let's start with the questions of this gentleman first. So are we talking here about a plant startup from a brand new plant, or is it after a revamp or after a shutdown? I think, Michiel, it's a little bit of everything, and depending on from where you start, you have more or less work, but perhaps you can comment on that a little bit more.
Yeah, exactly. If you have a brand new plant, of course you have really default tuning parameters, where you in a revamp situation, or let's say a new DCS, you will have a general idea where you need to start. But still, it's a great opportunity. A revamp or a new DCS is or a turnaround. It's a great opportunity to actually look at that PID tuning again and really optimize, because yeah, your hardware is changing, so your loops need to be looked at again.
Yeah, because that's also in line with the second comment that that person gave, is that at a certain moment he was asked to troubleshoot a lot of PID loops because they were all set at the same parameters, with a P factor of 0.6 and a TI of 0.4. Yeah, indeed. Yeah. So every DCS has its own algorithm, one which uses proportional band, the other one uses gain, and 0.6 as a gain or 0.6 as a proportional band, there is a big difference. It's a factor of 3 difference. So it is indeed extremely important that even if you think about default settings, that you know at least what algorithm is behind. So if you have to recompute your default standard settings, a little bit yes or no. And then another question from there is, what is the point of data collection if the plant is now starting up? So I don't understand completely the question, Michiel, but I think the thing is that, do you already have data collection in place if you are starting up a plant? Is that relevant? Or I think that is the question. But
yeah, well, of course the plant is not, well, starting up. To do the PID tuning, the plant needs to be running more or less. So maybe not optimal, but it needs to be running. And then really the data collection is all about using more advanced modeling tools to make models and tune the difficult loops. As you said, you can tune a lot of flow loops, maybe with some trial and error, but you really, in the difficult loops, the interacting loops, you want to have some feeling of models, and then you really need the data collection. Also, judging what is it doing. If you get a minute-based data, that's just not good enough. And on a DCS screen, usually you will have one loop, and if you click to another loop, you will see another loop. So you don't have the complete story. So that's usually why we set up the data collection.
So, but that means that you need something like IP21 or Pi, or something, or Exacquantum, or something which is built in a DCS that you can store and collect data on a 1, 2, 3, 4, 5 second basis, uncompressed, that you need anyway to do if you want to do decent work.
Yeah.
Good. Other question, what kind of hardware problems do you detect?
Well, the hardware problems usually are related to valves. Let's
Also
say
for brand new plants?
Yeah, also for brand new plants. Yeah. So sticking valves or not. For instance, we had a customer where we had a valve that opened in 10 seconds and closed in 2 minutes. So, and that was connected to a level. So these kind of problems you can detect, you will see, your tuning should be right, and you go into details and you see that it was just not configured right. So these things happen, yes.
And perhaps it's not considered as a problem, but valves also have nonlinear characteristics, which means that while you're starting up a plant, they are at around a certain working point with certain characteristics, and when you run at full throttle, then they are at other working points and other characteristics. So what do you do then? So you retune,
Well, yeah, that's also something to keep in mind. If you depending on the position that the valve has now, you should keep in mind that the tuning you put in should, keep in mind that you're running now in a valve that's not working very effectively. So what we do, we have our modeling tools, and we really shift between robustness, let's say, and fast tuning. So if you put at the faster tuning you can think of at that point, you move to another working point, it will be unstable. So that's something to keep in mind, and that's something to really, it's a judgment of the engineer. I'm not saying that you never have to go back to a loop. Just if you keep it in mind, you will be halfway there or 80% there.
Yeah. Okay. So that you don't have to iterate that much on every individual loop, or at least the complicated ones. Good. Another question, very interesting one. Can you do the tuning before the startup, or yeah?
No, you can't really do the tuning before the plant is running. So you can do the tuning if it's really just started up. You can already start the tuning, but if it's not running, you can't do the tuning. But what you can do is look at control structures and as I said before, identify problems you may encounter. I mean, if you know that a certain vessel, for instance, level vessel, is meant to be a buffer, then a certain tuning goes along with that. Or if you have another loop that needs to be a very tight controller or a disturbance controller. So that's something you can do in advance. So you can think of challenging problems and you really know what to focus on when you come on site.
Yeah. Another question, how do you find disturbance sources? For instance, yeah, you can have different disturbances, as you said. Ambient temperature can change, cooling water temperature, composition of natural gas, I don't know what. But there are also disturbances like one loop disturbing another one.
Yeah, exactly, yeah. So what you do is usually you put the loops in manual and you start to analyze, because if you still see oscillations, if it's the manual, it's not the tuning. So, and then of course, then really the process knowledge comes in. Where could this disturbance source come from? Is this another loop? And it's just all about analyzing what is this plan doing and which is causing the disturbances.
Yeah.
So that I would say is, let's say, process knowledge or analyzing your plan to identify possible sources and then look into detail there. Yeah.
Now, when can you decide or say after how much time of looking at the loop that you can say, okay, it works? Yeah. So is that a couple of minutes? Do you do some steps on the set point and then check it? Or so when can you say, okay, this one is okay, go next, let's go to the other one?
Oh yeah, that's actually a good question. Yeah, it depends. Of course, if you have a very fast loop, you can see it changes much faster. And it also depends a lot of the working point that the loop is running through. So if you have let's say a loop that is known to go through a large working point of your valve, you probably much spend more time making sure that in all working points this thing is stable. But this is also something what you do with your data collection. So you tune a loop and you reevaluate over a couple of days how was that loop performing, and that's much more, let's say, a constructive way of doing it than just looking at a couple of minutes. Looks good now, close it and move on.
Yeah.
So there's
yeah, good. Another question perhaps is okay, if you have to tune 500 loops or 1,000 loops, you cannot analyze them all in detail. So some trial and error, some default settings. Well, yeah, you still, for the ease of the project and the speed of the project, sometimes you have to rely on these ones. So, but when do you decide to switch from these heuristic things to methods to say, okay, now this one I have to analyze in detail because it's important. But how, based on what?
Well, actually, yeah, that's what you do is you just first the really easy loops, the let's say the fast loops, the flow loops, that sort of thing, you can easily do with a quick tuning based on a couple of steps and then moving on. But typically you do it with very slow loops with large delays, loops that you know will have an interaction, and then you really benefit from the model analyzing the interaction between things and then posing the right controller strategy. So yeah, there are some typical examples, but it is depending on the process. Yeah.
Okay, another comment. Do you agree with one of the comments is that you need a lot of communication going on, because well, we are very often on our own in the sense that we work quite autonomously to tune PID controllers, and then of course we have to inform the EPC guys, the licensors, the plant people, and so on. So we are doing our thing. We are tuning controllers when it is possible, which one are possible, and so on. And in the meantime, other people are doing other things. So how do you communicate and how do you organize that?
Yeah, that's also some of the roles we usually find ourselves in, because we communicate with all the parties on a regular basis. So we have on the one side the APC company, but in the other side you have the customer, and so we'll communicate with both sides, and of course provide reports on on all the loops we tune before and after, that you also that everybody knows what's going on and everybody is up to date which changes are made and why.
Okay. So if there are other people who still have questions, please don't hesitate to raise them. We still have a couple of minutes, not that long anymore, because normally we foresee 45 minutes for a webinar, so we still have a couple of minutes. But perhaps Michiel, one other that just came in. So these default settings. So is that something where you say, okay, often they work, or you just say don't bother? Okay, you have to put something in there, but
yeah, that's the thing. You have to you have to put something in there. So it is normal, and I don't say that these default settings that are posted are bad ones. So they may work. I'm not saying no, it never works. But there's a large difference between the loop is optimized. It cannot go better than this. The loop is working, or the loop is behaving badly. And you want to, of course, go to this loop is at its peak, let's say, and you don't want to get stuck in okay, default parameters is working, but yeah. So a lot of times these things work because otherwise no plant would start up, but there's a lot of room for improvements, I would say.
Okay. The last one perhaps is, well, you mentioned the example of the plant in Russia there, and the person in the audience had the impression that we changed some structures in the control philosophy during the startup. Is that correct? And
no, that's more, let's say, in the post-commissioning phase.
The post-commissioning phase.
Yeah, because
you have the licensor, you have the
you have the
IPC, which perhaps might not allow to say, okay, well, the last moment you don't change these kind of things.
Unless, of course, you have a really good
argument.
Good argument why something is not working. But I would say that's more post-commissioning phase where you can really take the time and really look at. It's not only helping you going faster to performance and acceptance testing, but also really looking at, can I optimize the plant? Can I make it even better? And can I save some energy, or can I improve on quality, or something like this?
Step 2.
Yeah.
Okay, good. Fine. Okay, so thank you very much everybody for attending and also raising the questions. Now, if by rethinking of the webinar you have more questions that pop up, please send them to me. I will ask Michiel to answer them, and I even will send the answer to everybody. So then, okay, the more information we can share, the better it is. So please don't hesitate to send me an email if you have more questions, and we will share the answer with everybody. The session is also recorded via a WebEx tool, which also means that if not today, but latest tomorrow, it will become available on our YouTube channel. So good. Now regarding the next webinar, we haven't set a date yet. It will be in next month in November, because we will do it from now on every month. So a date will be fixed later on, but the topic is already known. It's the optimization of incinerators, boilers and steam networks. And there is a focus also on waste incinerators, because that is something that we do quite often these days. Not only domestic waste, but you also have different kinds of waste, and I know that very big chemical sites also have waste incinerators. But there are boilers connected to it, steam networks, turbines, and so on. So, and the game that has to be played in these units is quite complicated, especially because nobody knows typically what goes in at the front end. Yeah. So thank you very much, Michiel. Thank you very much, everybody, for attending. So you will get an invitation for the next webinar. You will get also an email with the presentation in PDF format and a link to the YouTube channel, if not today, then latest tomorrow. So thank you very much, and we hope to see and talk to you soon.